Hello everyone. In this video, we'll discuss JEE Mains previous year questions of organic chemistry, and these questions are from 13th and 15th April. I'll explain you in detail each and every question, and almost 12 questions are there in this particular two sessions. And after this particular video, I'll upload one more video on different sessions. So now let's start the video. Let's start solving the questions. So first question is this. They are asking the product formed in the following multi-step reaction. This is simple reaction, right? So they have given this. Let me write it over here. They have given this propane CH3 CH double bond CH2. Here it is double bond. And yeah, first reagent they have given this B2H6, right? They have given this B2H6 and H2O2 and NaOH. This is hydroboration oxidation reaction. As we know that this hydroboration oxidation reaction will write the product according to anti-Markovnikov rule, and yeah, it's simply addition of water only. We'll get alcohol. So over here we'll get the product. Let me write it over here. This is hydroboration oxidation. I have explained you this already in my previous videos. You can check those videos also. And yeah, this is we'll get here CH3 CH2 CH2OH. We are just adding water according to anti-Markovnikov rule. If it is, yeah, now they have given one more reagent, that is PCC, pyridinium fluorochromate, right? So in the presence of this PCC is oxidizing agent, right? This will oxidize primary alcohol to aldehyde, and it will oxidize secondary alcohol to ketones. I hope you know this, right? So now let's write. So now let's write the product. Here it will convert this primary alcohol to aldehyde. CH3 CH2 C double bond O C double bond OH. This we will get, and then again they have given this CH3 MgBr. CH3 MgBr. Grignard reagent they have given, right? So now the CH3 minus CH3 negative, it will act like, here it is a Grignard reagent, and this CH3 negative acts like a nucleophile, and it will attack on this carbonyl carbon, and then this bond shift towards oxygen. Then we will get CH3 CH2 CO negative H, and here it is CH3. Here they should mention hydrolysis also. If you do hydrolysis further, then we'll get this secondary alcohol. But they have given directly options, you can easily get the answer, right? So this is the final answer. So option 1 is the correct answer, right? So let's see the answer now. See, we have got this answer. You can see the solution over here also. So yeah, now let's solve one more question. This question is from polymers chapter. It's simple. You just need to know about polymers and its particular monomers. I have already made one video on this particular topic. I have explained you in detail what are the polymers and what are its monomers. You can check that video. I'll give the link in the description box. They have given monomer here tetrafluoroethane. This is CF2 double bond CF2. This is tetrafluoroethane, and this is monomer, and its polymer is Teflon. So you can check like A is 3. A is 3. In these two options only A is 3. So you can eliminate these two options. And let's check one more. Acrylonitrile. Acrylonitrile structure is like this. CH2 double bond CHCN. This is the acrylonitrile, and its polymer is this Orlon. So this is Orlon, right? So B is 1. So you can take the option 1. B is 1 and A is this Teflon, and caprolactam means this nylon 6 only, and isoprene is natural rubber. If you know any of the two options, you can easily get the answer here. So I hope you got this. Here I have given the solution also, you can check this. And yeah, now let's see one more. Let me zoom it. So they have given this, consider the following sequence of reactions. They have given this aniline. Let me write it here. They have given this aniline, right? NH2, and in the presence of this reagent NaNO2, in the presence of 0 to 5 degrees Celsius, right? So this undergoes diazotization. It will form, let me write it here. This NH2 converts to N2 plus and Cl minus, benzene diazonium chloride. This is benzene diazonium chloride, right? And then they have given this NN dimethyl aniline. So the structure of NN dimethyl aniline is, let me draw it here. CH3. This is the NN dimethyl aniline. So they have this is benzene diazonium chloride, right? Diazonium chloride. And now this reaction is coupling reaction. Here this reaction is coupling reaction. Here, as we know that this group is electron donating group, so it will like, here will get negative charge and this will attack on this uh, nitrogen, and finally we'll get, if you want the detailed mechanism, just let me know in the comment section. I'll make one more separate video for that. Then we'll get here, simply here azole linkage formation takes place this way. Here we'll get this azole linkage N double bond N, and then this N, and this is the final answer we'll get. So you can check the options. This is our correct option, right? Option 2, N double bond N. This is azole linkage. And yeah, that's it. This is the correct option, so you can check this. And if you want detailed mechanism for this coupling reactions, just let me know in the comment section. And now let's see one more question. So you can see the solution here. Here it forms diazonium chloride, and this is diazo coupling, and it will form azole linkage. This is azole linkage and double bond, and these generally it shows color due to their extended resonance. So yeah, now let's see one more question. You have got the answer, right? This is the correct option. And here the next question is, they are asking decreasing order of reactivity towards electrophilic substitution reaction. So here they are asking reactivity order towards electrophilic substitution. They have given here almost all are benzene rings. So let's say for example one electrophile is there here, electrophile means electron deficient, right? So in case if you have any electron donating groups on this ring, it will the reactivity towards electrophilic substitution reaction will be increases, right? In case if it contains electron withdrawing group, it withdraws the electron, so it can't give electrons, and the reactivity towards this electrophilic substitution will be decreases, right? So you just need to check the is there any electron donating groups are there, then its reactivity will be more. That's it. So let's compare. Benzene ring should contain more electron density. So yeah, now let's check this. This NME2, right? This one. This is more electron donating group than this OCH3, right? So it shows here plus M effect, mesomeric effect, and this is also shows plus M effect. But here the it shows like inductive effect towards, like it contains these two methyl groups also there, right? Here the electron density on this nitrogen will be increases, and it can participate. The resonance will be more effective in this case. So the reactivity order, this E is greater than, then you can say this has more reactivity towards this electrophilic substitution reaction B. Then after this is electron withdrawing group, so it will be lost, right? So C will be last. So you can eliminate these two options. Option 1, option 4 you can eliminate easily. Option C should be last, and then this it shows plus H effect, right? Hyperconjugation it will shows, like it shows hyperconjugation. So A, and then benzene, and then the C. So the option 2 is the correct option, right? C E is greater than D, then A, then B, and then C. So I hope it's clear. So yeah, you can see here, higher the electron density on benzene ring, higher its reactivity towards this electrophilic substitution reaction. So you can check the solution over here. So let's move to the next question. So here they have given the reactant they have given and the product they have given. We just need to find the reagents. Right. So yeah, now let's check. So let me write first this CH3 NO2. As we know that this NO2 is electron withdrawing group and this CH3 is electron donating group, right? So first here in case of in so here in this product we have this bromine, right? So first let's do bromine. Like let's do this. Let's substitute this bromine first. So in order to take that, like we can take this reagent, that is Br2 Fe, right? Then we'll get here, as we know that this is sorry, as we know that this EDG, electron donating groups, are ortho and para directing groups. So para is not free, so it would attack on this mostly. And as we know that NO2 is electron withdrawing group, so it is meta directing. So in any of the position, this bromine will be substituted. Here it is CH3 NO2, and let's say here it is substituted this bromine, and then here we just need to convert the CH3 to COH, so that we can take this KMnO4 over here, right? So just let's forget about that. So if you see this option, first we have done this, we have substituted this bromine, and then try to convert this into NH2. In order to reduce this NO2 to NH2, we can take any reducing agent. Here they have given this FeH plus, right? This is as like reducing agent, and yeah, we'll get this CH3. It will converts to NH2. The basic idea is to replace this NO2 to Cl. We can't do that directly, right? That's why we are trying to convert this into NH2, and then we can treat with this HNO2, and it will convert to diazonium chloride, and then we can replace that with chlorine very easily, right? So yeah, now let's take this HNO2 reagent, or you can take like NaNO2 plus HCl also. Then we will get here CH3Br, and here it will convert this N2 plus Cl minus. In order to convert in order to replace this group into chlorine, we can take this CuCl. The replacing of the N2 plus Cl minus with halogen, those reactions are called Sandmeyer reactions, right? So yeah, it's easily replaces this with Cl, and then we have got almost our product, but we just need to change the CH3 to COH. This is oxidation reaction, like we can take this KMnO4 oxidizing agent. It will convert this to COH. The condition should be here the benzylic carbon should contain at least one alpha hydrogen, then only it will convert to this acidic group. So I hope this is clear. So option 3 is the correct option. So you can check the remaining options also. First they have given this reducing agent, so it will convert this into NH2, and then they have given this HNO2, and then it will convert to N2 plus Cl minus, and then it replaces with Cl, right? And then KMnO4, it will convert to COH, then Br2. But in case this will become COOH, and this will become NHCl, right? As we know that COOH is electron withdrawing group. This favors meta substitution, and this chlorine is an electron withdrawing group, but it favors ortho and para directing group. So it will be like here. So we'll get bromine over here. So this option is wrong, and here over here also they have given this KMnO4 first. KMnO4 means this will convert this CH3 to COH directly first, and then they have given this Br2. So COH is B meta directing group, and this NO2 is also meta directing group, so it won't be that much favorable. And you can check the last option also. uh, First they have given this, so yeah, it will substitute bromine over here, and then they have given this, but they didn't mention this HNO2, so we can't replace this NO2 to Cl over here. So yeah, finally we have got this. Option 3 is the correct option. So now you can check the solution here. Now let's solve one more question. The major product A formed in the above reaction. This is simply like, see, whenever you treat these ketones with water, it will form gem diols. Let's see how. See, this will attack on this particular carbonyl carbon, and then we'll get this O minus and OH2 positive, right? Let me write it like this. H, H positive. So this will obstruct this hydrogen, and it will form this gem diols. This is gem diols. Generally these are unstable, but yeah, you will get gem diols when you treat ketones with water. Here there are three types of ketones over here, but you can check. Let me write it over here, and then let me explain. C double bond O, C double bond O, and C double bond O, right? So just wait. So here you can check. Here also C double bond O. Here also it's there. Here also it's there. Where this water should attack, you should like, let's check the del positive on each carbon, each carbonyl carbon, right? So yeah, if you check over here, it is participating in resonance, right? So the overall positive charge del positive will be decreases due to this resonance. Here also same situation, right? So the del positive on this carbon and carbon is more, so this will attack, water will attack on this carbonyl carbon, and it will form gem diols. So we'll get the product like this: C double bond O, OH and OH. This is our correct option. So where is our correct option? Option 4 is the correct option. So you can see the solution over here, right? And there will be an hydrogen bond also exist here, right? So yeah, now let's see one more question. Here they are asking the major product formed in the Friedel-Crafts acylation of chlorobenzene. So chlorobenzene, let's draw this chlorobenzene. This is chlorobenzene, right? And they have mentioned this Friedel-Crafts acylation. Let's take CH3, C double bond O, Cl, and in the presence of anhydrous AlCO3. So as we know that this will undergo electrophilic aromatic substitution reaction, right? And one more thing is that here Cl is electron withdrawing group, but it is an orthopara directing group, because see here you can check it. Let me explain it over here. Generally this shows minus I effect. At the same time, it shows plus R effect also, resonance, right? Due to this minus I effect, it acts like a electron withdrawing group, and yeah, due to this plus R effect, the deactivation on ortho and para positions will be decreases. So yeah, that's why it is an ortho para directing group. So it will substitute on ortho position and para position, but the major product will be para, because less hindered will be there, right? So let me write over here. So I hope the reason will be clear for you. Cl, you'll get this C double bond O, Cl, and one more product will get ortho product, but they are asking major product, right? Here due to steric hindrance, it's not major product. Para is major product. This undergoes allo- electrophilic aromatic substitution reaction. So I hope it's clear why Cl is orthoparadiating group, right? So the option 1 is correct option. Chlorine and this para position, we have this group. So let's see. See, you can see here chlorine is an orthopara directing group. So para is major due to less steric hindrance.